I'll start with just 2 to 3 minutes on kind of the experience of teaching algorithmic responsibility actually for the first time this past March. It was an interesting time for us to be teaching a class on algorithmic responsibility. It started just as the pandemic was ramping up in New York. And about halfway through the class, you started seeing all these news articles on Google and Apple teaming up to create an app or a monitoring app that can report on who and how you were in touch with or in contact with related to COVID-19. And then you also had obviously lots of reports on other countries, China specifically, and the monitoring apps that they were putting in place. And it really underscored for us, and for our students, the moral complexity of navigating the space. It's not easy, and it's not something that you can just say, okay, no, this is wrong, right? We had that instance, which both Reece and I were quite involved with in 2016 with Facebook, where it almost seemed a lot easier to say, open book, this is overstepping privacy boundaries for Facebook to have targeted us in that way, and it was much easier to have a moral position on it. Whereas here, you're saving lives, but at what point does monitoring and privacy during times of danger open up doors that you can't really shut again? And so that turned into a big part of the conversation in our class, and we'll touch on different areas of that today. And it all kind of comes back to, for us, to corporate and to HR, because the roots of deeper signals was to create a passive assessment tool. When we started our company, our mission, which has drastically changed since then, was no one should have to take an assessment. This is pre-2016, so the idea was everyone should just get their personality profile, and it'll be so simple and slick, and everything was about technology and automation, and privacy wasn't really on everyone's radar. And then Facebook and Cambridge Analytica happened, and the election happened, and we all started talking about the idea of the trade-offs that we are we're accepting for engaging with these tools, and as a company, and also as as people and practitioners, we realized we didn't want to go down that road. We actually preferred to create a tool that was as engaging and as exciting as possible without dealing with the potential of transgressing on personal boundaries. So it all kind of comes together with this idea of algorithmic responsibility and how you can help people with algorithms use them because they're inevitable, but do them in a responsible way, and our responsibility to do that. And so just to start with, right, what is an algorithm, right? Really, from the basics, what does it mean when we talk about there being an algorithm, right? A process or a set of rules to be followed to create some kind of, you have a problem and to create some kind of solution with it. The core ingredient of an algorithm is always the data. So you have some kind of data and you set some kind of structure in order to solve the data. And it's usually, skipping to number 2, it's designed to be reproducible, scalable, and provide, the key is a quick solution to a problem that otherwise might take a lot of time. And that's always there in an algorithm. It's a quicker solution than what otherwise you'd have to do. For example, if I don't have automatic Netflix recommendations, well then I may have to think about what I actually want to watch, and that's a problem. Netflix doesn't want me to think, or Facebook is another good example, right? If I have to consider my opinions on a news event, that would be problematic too. Facebook can actually just tell me, hey, you thought that last time. Here's something that's similar to what you thought last time. Why don't you just think that again, and then you don't have to think. So that's a bit of a cynical take on it, but that's what these algorithms are trying to do, get faster and faster and faster at enabling us to take shortcuts. The problem with algorithms is this concept of when do they transition from being helpful shortcuts that help us navigate the world, and shortcuts that we do naturally as humans as well, and they transition to what we call weapons of mass destructions. And that's a term coined by Cathy O'Neil. I don't know if any of you have read that book or heard of Cathy O'Neil, but love her book, and we base a lot of what we taught on the concepts that she writes about. And so that idea that if an algorithm has 3 core characteristics, it is a potential weapon of mass destruction. The opacity, so it's really unclear. It's too complicated for the average person to think about. Unfairness, so it has the possibility, its impact can lead to unfairness, and we'll talk about that more, but obviously most algorithms fall into that at some point down the line. They fall under that category of they could have an unfair impact. And scale, right? It can be impacted on mass scale. If you have those 3 things, you know you're dealing with something which could be a weapon of mass destruction, and you have to really think about it.
I think just to jump in here as well, it's the idea of how prevalent these algorithms are. I think it's now very clear that everything that we do in this kind of hyper-connected way of living is generated by some sort of algorithm. It doesn't have to be a complicated one, but they're there. And as Uri said, it's all about trying to make it quicker and faster to make decisions. However, the problem is that, these algorithms kind of have very, very, real consequences. Our desire to kind of bring more data to the conversation in the hope that it makes us actually more objective, starts to lead to this unfairness, especially when we can't really explain, how and why it works. I think this is ultimately kind of where we're heading, is that as you start to have a more democratized and commercialized application of AI, of algorithms, you start to invite people that are otherwise untrained or uneducated in the space to start using them, which, is obviously a good thing. We want to have, give everyone access to helpful tools. However, it's when those tools can't really be explained how and why your data is producing these predictions. And when they're really being kind of applied in ways that may not have necessarily been considered from an interdisciplinary perspective. For example, and we'll dive into this as we go, but the idea of, say, computer engineers creating algorithms and platforms for social communication and, technically able to do it. However, a lot of the interesting humanities and social science research that we know about how communication plays out, the idea of a social contract, reciprocity, and so on is kind of lost. But then from there, it's this final point on the screen where we start to kind of really run into problems, which is when these algorithms are in concert with each other. And if you think about how integrated all of our systems are now, even say within, pick your ecosystem of choice, whether it's Apple or Google or so on. That's a closed environment that's sucking up, all the data from your digital footprints, that's feeding on of itself. And from what we know from, like, say, just evolutionary principles, when you have closed systems, you have, kind of weaknesses are introduced into that kind of gene pool. And it's the same way to think about algorithms. The more that you kind of introduce and make them dependent on each other, you get very quick and very impactful structural flaws. I think we've seen that in the finance industry, where you have kind of flash crashes from algorithmic trading, where everyone is kind of making derivatives of the same algorithms, and then something kind of goes haywire. You can't explain it. It's clearly unfair because, money is kind of being traded and being lost, and it's at scale. It's affecting the global economy. And so it's this idea of how these prediction machines, they're all designed to make our lives easier, faster, and better. And more often, generally do those things.
And very often more fair as well. So we're going to go through a bunch of examples now to kind of set the context. Examples that we took from all over for how these algorithms have, in fact, impacted people in an unfair way, but very often were created with the lofty goal of, helping the world, making the world a better place, as Silicon Valley always is apt to say they're doing. So one really good example of this is teacher performance, which was in the news for a while, where you had a bunch of researchers, if I recall correctly, it was from Princeton, who came up with an algorithm that can assess the performance of a teacher based on test results, student ratings, student performance, student level in the next class compared to the previous class, and a lot of magic and statistics. And a teacher then was ultimately rated And if you fell below a certain level of performance, you are at risk of being fired. But what ended up happening in this situation is, and what they didn't necessarily take into account, or at least we don't know they did, is the previous year's teacher could hack the system a little bit. Where if I made a deal where you decrease the level of students or don't really teach that well, then the next year's teacher can really increase the level of the students, and then that seems like a really big jump, so that's a really good teacher. Whereas if the teacher below might have then done a really, really good job teaching, and the next year's teacher, there's a lot of duplicative content. So there was a lot of unintended consequences, and there was a teacher that ended up getting fired and doing a lot of research in the public school system with freedom of information requests to get access to the algorithm, to understand why, despite being a really good teacher, she was let go, and she wasn't able to access the information to prove it, because you have that problem of opacity, right? This is our IP, and we can't disclose how this algorithm is working. And if you can't disclose how it's working, you can't properly look at it as a researcher or someone in corporate HR, for example, who has responsibility to make these decisions and decide if it's fair or not. And so that's always a big red flag. Another really good example of this is in predictive policing, which is a great example for when we create algorithms with really good goals. And this is both predictive policing in terms of predicting where police should allocate resources. And obviously current events make this super relevant. But even more importantly is recidivism algorithms, which is when we have algorithms to help predict whether someone will commit a crime again, to set bail, or to decide how long a sentence should be, right? And so if you think about it, the idea is great, because if I could really predict, as every judge wants to do, whether or not there's a risk of committing another crime, then I can let more people out on bail. Maybe I can get rid of cash bail, which is a really good goal probably, and instead use some kind of magical algorithm that helps me understand whether someone's going to commit the crime again. And it doesn't have to cost money. It's not just a matter of wealth. So all those goals are really good, but obviously what ended up happening in those cases is, Reece, to your point about reinforcing algorithms, right? There's bias in the system. There's bias, humans in the system that start this algorithm and train the algorithm that people who come from certain communities, who have certain levels of income, or who look a certain way, are more likely to commit to recommit the crime. They're the ones who get harsher treatment, and that causes them to actually either commit more crimes or become part of communities that we then flag for committing more crimes. And there was this vicious cycle where it turned out that what was predicting it wasn't anything about risk, but actually just predicting what the algorithm was predicting. And so those are areas where you start off thinking, if I can get this algorithm right, I'll fix the world, and you end up really breaking the world. I think we're going to talk about it soon, but the answer isn't necessarily to throw the towel in, but obviously to do a much better job. And I want to challenge myself and all of you for a second to think about, without getting political, if we were to reverse this kind of algorithm, how hard it would be to say whether we should try it or not, which would be, let's say I can come up with an algorithm to predict whether a police officer is going to commit harassment or some kind of extreme behavior that we've been seeing in the news now. Well then, obviously that would be super valuable. Maybe I can fix the whole policing problem, right? Or would that itself turn into some kind of unfair predictions and processes that we don't intend to do? So I think that's why the whole topic here requires a lot of thinking.
And I think from HR perspective, it's even more important, just because a lot of the applications that we bring in AI or our algorithms for are impacting human lives directly, their jobs, their livelihood. So
yeah, 1000%. Yep, and that's credit scores is another good example. And I'll just move to the enterprise software, Stella, because you brought it up. But in enterprise software, obviously there's really important implications for being careful with algorithms and using them responsibly. So I remember when I was in corporate, right, the idea of predicting, for example, predicting employees who may leave the company, so retention, and predicting performance, obviously for succession plans, those things were the holy grail. And as a researcher, I can take any data in the organization and do any kind of cool thing, stick it into my flat file. How many columns can I add? We're all quite well aware of this, right? To get that prediction and then prove statistically that I've gotten a good prediction, and my manager's really proud of me, and I was new out of school, so it was all really good. Can I take the unstructured data and put it into text and show sentiment, and then the sentiment analysis is going to ultimately predict the retention, and it was all great, except no one knows what they're doing, right? And then that's how it has unintended consequences, because some of the columns of data that I took could have come from another algorithm that no one ever intended to be used for this. It was just logged in the HRIS system as something that's never going, this is a high risk column. It's never going to be used to actually impact succession or promotion or salary. But then another department in the organization uses it for just that without even realizing it.
Yeah. And then I think just to kind of follow that, it's this idea, I think with over the last kind of 5 to 10 years, as the AI, machine learning, big data trend has kind of grown and blossomed, we've all been trying to put more and more data into the conversation, because it's like, yeah, humans are biased decision makers, and data can, bring objectivity. And while yes, that is true, it's really important about thinking critically around what is data in and of itself. How did that data create? How was that data created? Who programmed that? How is it generated? How is it stored? How is it manipulated? That's kind of the things when we talk about algorithmic responsibility. It's really around putting the technology aside. This isn't necessarily a technology issue. It's much more of a human social kind of issue in the way we think, the way we solve problems. That's where we really need to start tackling things. If we're going to fix and diffuse weapons of mass destruction. But just one other comment I want to make while we're talking about enterprise software is you may have seen reports as well of, as now organizations are switching more to virtual working because of COVID, and then seeing the benefits of that, and continuing ahead to staying at virtual companies. We're seeing more and more organizations installing snooping software into people's devices. Now, I think you can, why it's obviously a bit creepy, but you can understand from a corporate perspective why you would if you was working in the office. It now branches over into a new level of a kind of privacy infringement when you are monitoring people's computers and online activity at home. And then from there, it's like no one's actually observing you. And they're monitoring kind of your keystrokes, or kind of how many times you're uploading or downloading files and so on. I mean, again, how does all that data come together to show whether someone's being unproductive or productive? For example, I know a few people already that have this software in their computers, and they find software that you can just download that moves your mouse at regular kind of intervals, or kind of uploads and downloads files every now and then, so it looks like modified at so-and-so times. It's like that, and this is it. It becomes a bit of a cat and mouse if you just chase the algorithm.
To interject with just a funny story that just happened. We did like a family Zoom session, and I have quite a large family, so there's about 20 people on there. And at some point, my mom asks a question to my maybe 12-year-old nephew, and then there's no response, and then there's no response, and then we realized that he learned how to take a screenshot of himself, put it on his screen, share his screen, and then he just went off to play his video games and didn't have to take part in the session. And he's 12 years old, and it was just a brilliant example of how quickly these things evolve. He probably didn't know how to use Zoom 3 months ago. So yeah, so assessments is another great example of enterprise software. It's obviously something that's super close to what we do, because Deeper Signals is an assessments company. But it is a great example of something which is really baked into our enterprise enterprise software packages, and something that most companies in some way, shape, or form use. And maybe 10 years ago, you wouldn't have called it an algorithm because we weren't all talking about algorithms. And yet assessment is just another kind of algorithm. It's another way for us to collect data and draw conclusions from it that we otherwise, either wouldn't be able to have an opinion on, or would use our own personal heuristics and probably biases to do. And so it's an algorithm that we hope is less biased than the algorithm in our brain. And obviously, to some level, data has shown that it could be, but if misused or used in the wrong way, it becomes just as faulty, or maybe more faulty than the algorithm in our brain. And it's not true, as we'll keep on underscoring through the rest of the presentation, it's not true that just because it's AI, just because it's cool, just because it's data and numbers, it is any better than the algorithm in our brain. It may or may not be, and that's what's critical. So you go from what seems to be sound science of personality assessment, well proven over and over again to actually differentiate between people, to maybe even before AI and computers and sensors, maybe using it across the board to predict certain factors that we've learned actually predict performance, like conscientiousness and drive. But then, even in that case, use it in the wrong context, use it maybe where conscientiousness is not needed for the role and drive is not needed, or use it to purely predict who is similar to the other people who are doing well in the organization, which just so happen to be white men. And you end up, with bias that you may have even avoided with a concerted effort and without the algorithm. So there's a quick jump there where if you're not careful and thoughtful about it, then you quickly skip over from helping yourself to hurting yourself. And that becomes even more treacherous when you switch to the tools we're seeing enter the lexicon now, which is, video assessments, where we're mapping facial features, and we have, higher view would be a good example, when they advertise. They may not be advertising it anymore because it's not so in vogue anymore, but back when they started, they were advertising, we have 100,000 different variables that we map on every single assessment that we do to predict performance. And it sounds amazing, and it's like it's prophetic, or who can ever interpret 100,000 variables? And if we can't, we don't know what it's predicting. And very likely there's bias in there. So how do we control and think about that?
Yeah, just to add to that, it's this idea, I think it was Kant that said, like, theory without data is meaningless. Oh no, theory without data is nonsense, but then data without theory is madness. It's exactly that. It's this idea of, if we're going to, prediction doesn't mean science, and that if we're going to use algorithms, we need to be able to explain kind of the whys and hows. But more importantly, like, what are we trying to really predict, and what are we really trying to measure? And then it's about not using algorithm as the solution, right? I think it's the theory and the reasoning, the justification that should be the solution. It's the algorithm is just a mechanism to kind of make that happen.
Yeah. And one last example that one of our students actually taught us in the class that we gave was corporate wellness programs, which might be apparent to some of you if you're in corporate, but I would have thought is quite innocent and helpful. And she was showing us some examples where the corporate wellness program were incentivizing them with cash. So $10 bonus or $25 bonus to share with them data about their 401k, data about their financial investments, etc. And after going through the class, she started questioning, why are they nudging me? Why is this company asking me for this information, right? And we dug down, we did research, and we learned about how so many of the companies, and I think it's the $40 billion corporate wellness industry, are essentially shopping data, right? And with opting in and knowing everything about you, from wearing an iWatch, and so getting all that information and sharing it with the app that's on the watch, and etc. They're able to predict things like who is pregnant, or maybe who's going to become pregnant, or who's healthy, and what kind of cost are they going to be to my healthcare system. And then I can predict, if I can predict that, I can predict the costs they're going to be and the investment, and whether I should keep them or not. So you can see how that quickly goes from something super positive and something you'd encourage every organization to have, to just being another tool in our toolbox to monetize these things and predict things. So yeah, everything needs to be questioned was our takeaway from that. So, I mean, how does what powers all of this is the fact that we go around the world. That's the iWatch idea, but these days we move around the world and we are literally leaving a digital exhaust, and it's just a stream of data. We're doing it right now as we speak, and there's We're using our laptops and our phones. We're on our phones. Someone knows that we're on a meeting. In this case, it's Zoom, and et cetera, and et cetera. And that exhaust never stops, and we can't help it. We can't stop it. And so the problem isn't going away. If anything, it's accelerating, as is our responsibility to think about how we use these tools and this data and this information in a moral and constructive way. And I say that because I genuinely believe, from all my research into this, that the corporations, the companies, the vendors that have the potential to make a lot of money off of this will never stop. They will not be the ones putting up moral guardrails. It'll ultimately be us in HR, in organizations, in procurement, who create less of a demand because we're actually ethical and prudent about it.
And I think when we talk about this data as well, it's really important about thinking deeply around what does this data point really actually mean. For example, looking at, say, your browser history or kind of the number of clicks on your screen per day or something like this, you know, on the surface of it, to someone that isn't necessarily trained in behavioral science, thinks, okay, it's just an innocuous piece of data about kind of, you know, the websites that they browse or kind of the frequency they use certain devices. Yet in our own research, both independently and looking what's on the field, is that you can get a vast array of seemingly, you know, meaningless data, and with very, very, very simple off-the-shelf algorithms and just a bit of data, you can actually reveal how they predict really deep, meaningful attributes about, you know, someone's dispositions, their sexuality, as you see in this screen, their political opinion, and so on. Things that we may otherwise hold true to be private attributes are, with enough data, deeply, deeply revealing. And so, for example, on the previous slide, an advisor to Deeper Signals did research to really shine a light on this, and found that your profile pictures can be used to reveal your sexual orientation. Now, while the article, as you can see from The Guardian, it got a lot of pushback, but what the study was really trying to prove was how off-the-shelf tools can be used by governments around the world where being homosexual is a punishable death, right? And so the idea being that you can take these tools, seemingly think that you're not communicating anything, but then with very little technology, they can be used in a very harmful way. So a more kind of recent example is continuing along with facial recognition and kind of demonstrating how it is nearly always, no matter what algorithm or software that you use to do facial recognition, is misclassifying people depending on their ethnicity. And so this is more topically relevant, given that I think it was Amazon's recognition platform, as well as IBM, and I think Microsoft have now stepped back and said they're no longer using computer vision or selling computer vision solutions to law enforcement agencies because of these reasons. Despite, you know, them being the companies that you see here that have created these algorithms, you can start to see, if you live in a more surveillance state where AI vision is kind of being used to identify people and misclassify people as being, you know, potential convicts or not. And then when you layer on race and ethnicity, you can definitely see how these things can be abused, and then only go on to feed into those other algorithms that are used in predictive policing and recidivism. And so then you start to get this echo chamber of 40 algorithms building on top of each other. But if you just go to the next slide, Uri, you know, the reason why these things are broken or work ineffectively is not the algorithm itself. The algorithm is just a statistical formula or a set of rules that is processing whatever data you've given it. And so when we talk about algorithmic responsibility or morality or effectiveness, the first step is always like, what are your inputs? Garbage in, garbage out is kind of always the way to think about AI and machine learning. And so in the case of computer recognition, facial recognition, sorry, we can see that overwhelmingly the types of people that are used to train these algorithms are white North Americans. And so no wonder why these algorithms are kind of misclassifying people. The algorithms themselves are not inherently racist if you think about it from a technical perspective. However, the data that has been fed into it definitely is. And so this is actually a problem for all of the psychological literature, from spanning all of IO psychology and social psychology. It's most of the research has been done on Western educated students. And so when we talk about kind of generalizations, when we talk about the validity or accuracy of, say, assessment tools within the HR space, yeah, they work for a particular certain person. And so when we're communicating this to our students that are, you know, eventually going to move on to become assessment buyers, it's always about looking at the technical specifications. You know, a good assessment company will share technical manuals, and it's important that you read them. And, you know, it's very easy to spot kind of shoddy ones. If you dig a little bit deeper, they'll see that it's only maybe built on, say, 100 people, and the diversity in it was kind of mostly men of a certain age. And then like, well, okay, so now that's an algorithm that you're going to then use across your entire graduate population to find, you know, new talent. Like, that's inherently broke, and you're then only going to further instill kind of bias and a lack of diversity within your organization. It's as well as realistically not driving performance, because if you're sampling from a homogeneous sample in the first place, there's going to be a lot of intra-person difference that isn't going to be accounted for by those algorithms.
Yeah.
And this is an example of just how we did it, right? So we, as a proof of concept, we had people complete, you know, very short biographical interviews, and then we just used a tool that Amazon makes freely available. We collected their personality, and then was very, very quickly, within a matter of hours, of being able to build a personality detection algorithm that had like around like 60–70% detection accuracy, which obviously is large given how quick and easy it was to make it. And so the takeaway here is how easy it is for these things to be used and abused. Like, if you don't really kind of think it through, think about how you're collecting the data, the sampling, diversity that goes into it, and also the accuracy and validity of the inputs as well, right? If you're measuring personality traits, or you're trying to predict performance, like, how reliable and accurate are those things? I think in HR, we all kind of know that performance appraisals, performance variables are very, very shoddy, right? And it depends on kind of what kind of performance you're looking at and kind of who's rating it. If you've got an unreliable outcome, you can make an algorithm that predicts that unreliable outcome. However, it's going to be fitting to the noise. And then within that, it's going to introduce a bunch of random, strange, and ultimately unhelpful predictions. And so
a great example of that is, well, we'll talk about it when we talk through the 5 solutions. But you know, you always have to be thinking about what it is that you are actually predicting or measuring, not the logical conclusion that comes from that. All right, as Reece just said, you can either say, I've predicted that this profile is going to be a high performer in my organization, right? Or I can look at all the characteristics of the people that I have looked at, and that I set as a benchmark, right? The performance ratings, and I can look at who set those performance ratings, and I can rephrase it and say, well, when 90% white male senior managers give positive performance ratings to this group of people, then I can predict that people similar to them are going to perform well. Now at least I've set everything on the table, and then we can have a conversation about it, and is there enough diversity there to draw conclusions? But you always have to state it as it is, at its most raw format, in order to properly assess what's going on. I was talking to a friend of mine who's at MIT doing self-driving car development. He codes self-driving cars, and we were talking about the problem that they face, which is actually one of the largest challenges that they have in detecting humans on the road. And think about how serious this is and how serious it can impact minorities. You know, so the car has to detect if it's a human or not a human, and it behaves differently based on that, obviously. And 80 to 90% of their test data are going to be people in North America, because that's where 90% of self-driving car research is developed, right? So if that person is someone that would look like a North American, all different features, then great, we'd have a great, easier time predicting that that person is a human versus if it's someone that looks differently. It could be a Black person, it could be a minority person, it could be a shorter person in general, but overall, there will be a decrease in the predictability in those cases. So what happens, of course, when we take self-driving cars to other countries, when we start exporting them, but if even in the US, are we just going to end up with a greater risk of hurting minorities than hurting the average person on the street? And so those things are super risky and super big challenges for the self-driving car industry. And it goes back to stating the problem exactly how it is. I can call it my car can predict humans, and this is what he was telling me, or I can call it my car can predict white humans with X%, and my car can predict, and no, actually, if I really look at it and I include that in my data set, I can say my car can predict, I don't know, I'm just making up, white male humans because they happen to be on the street more often. I mean, that might or might not be true, but that's the idea. You constantly have to keep on decreasing or drilling down to describe the prediction in order to really say it for what it is. This is an example of just one company, and I'm not throwing them under the bus. Humanize is a great company, but just to underscore how much data can be collected. They if you haven't heard of them, they provide kind of necklaces or tablets that every employee wears, and it's GPS enabled and Bluetooth enabled. And so the data that they look at is literally everything: how many steps you're taking in, how many times in the office, who you're speaking to, how many people are in a meeting, and so on. And so it underscores how much valuable information you can get from it, but how complicated that data can be to really hone in on what you are or are not predicting. Just take a quick pause before we go on. Is there any questions or that you're getting in the chat, Celiona?
Not in the chat, and I would welcome people to unmute and ask questions. And meanwhile, I do have a question. So if you think about COVID and the requirement for everybody to wear masks, that definitely is going to throw a big wrench in the facial recognition to begin with. But number two, I think a lot of the models that were built on the data before COVID may have to change just because our norms changed, the types of data we're seeing, the prediction. So how do you think this, in general, the AI space is going to evolve with COVID being such a big disruptor to everything?
So I take the first part of that question, which is something that the answer I learned from, again, one of our students. So part of our course, we have them give a deep dive presentation on a particular aspect of AI and algorithms. And she shared that the most telling part of a person's face when doing facial recognition is kind of the distance between the nose and the eyes, and kind of the wideness of the eyes as well. And so the fact of wearing a mask, of course, kind of decreases the accuracy, but technically we shouldn't see that much decline. And I think I saw somewhere that Apple has just updated their Face ID algorithm to be able to take into account people's masks as well. So maybe what I'm trying to say is maybe these algorithms are maybe a little bit more robust to change than we think, because their ability to pull out patterns and data points that to us are unintuitive, but are kind of really telling. I mean, this is the whole value of algorithms. But you're absolutely right in terms of going back to that self-driving car, is this idea of change. And then so keeping it actually back to HR itself, when we talk about, say, attrition models, like who's going to leave the organization? Well, now the last 3 months of data completely throw a spanner in the works. And I don't really think, aside from maybe some big kind of life circumstances that would predict whether you're going to leave the firm, I would imagine all the other variables that would have always gone into those algorithms no longer matter. And so now we're at the challenge of, well, first of figuring, okay, what does the future of the workplace actually look like? But then two, all of our metrics are kind of now just shooting in the dark. And so the challenge here is, are we going to be confident enough to actually scale back some of the applications of our HR algorithms? Because now we know everything's changed. Our confidence intervals within our algorithms are going to be even wider. Should we kind of put a moratorium on them? Wait till we get 6 months worth of data, train, validate, test them? or are we going to continue to barrel ahead and use them? I suspect, rather cynically, that people are still going to rely and use them as they are. Partly but just because we know change is difficult, and modifying algorithms is also difficult.
And to your point, Reece, if now it's the predictability of face for security reasons on the iPhone has now gone down because of face masks, no one's going to stop using photo recognition on their phones. Whereas we might have all questioned it if the recognition was bad when it first came out, but now it's too late, right? And so we just hope that Apple has managed to keep up the reliability together with updating their algorithm. So
but this is it. It's like that track and trace kind of approach that we're seeing being used around the world, of course, has tremendous value for stemming the tide of infections. But it does introduce this idea of, kind of the foot in the door technique, where we're giving up like a bit of our personal freedom to kind of solve a very important problem, and then we get quickly inoculated to it, and then more and more kind of privacy is taken away, which we've already seen already. This isn't new. We've seen this over the last 20 years as personal computing has become more mobile and more.
And it's rather ironic to get borderline political, but not political. But it's rather ironic to think that the debate that you see going on out there is, the freedom of having to wear a mask or not wear a mask, or the freedom of being able to move or not move. Is the government going to take away our right to move if they put us in lockdown in the future? No, they won't. But that's not how it's going to happen in the future. What will happen is tracking and tracing and monitoring and data. That's where freedom is eroding, and that's where, if anything, we have to have our wares up, not physical freedom. That's olden day stuff.
And Tony, I saw that you're going off mute. Do you have a question?
Yeah, I do. So fascinating stuff, guys. Really appreciate your time. How does this take into account how cycles in a human's life may affect performance on some level? Because we all go through them, right? Sick spouse or whatever. How does that take into account? Because they can be measured on a cycle in their life, which is not really good. And how do you, and again, it comes back to me to corporate, a balance in the corporate mindset, I think, on some level, not utilizing the bad versus the good. Make sense?
Yeah. No, it absolutely makes sense. I think it's a great question. To me, that falls into the framework of that should be part of your statement when you're stating what your prediction is doing. And in that specific case, we, as a researcher, we might say, okay, there might be 5 people here who are going through certain stages in their life, but we have 1,000 people in the data set, and we can safely assume we've normalized it and we still have a valid prediction. So it's not to say that we can't use data to make any predictions in science and statistics to try to understand the truth. But if that's the reality, then just like there's other dependent variables like age, maybe life cycle, maybe environment, maybe COVID-19, all these things need to be on the table. We have to say all of these things are included. We've controlled for A, B, and C. We haven't controlled for X, Y, and Z. We can only say the following conclusion from our study.
Yeah, and then to add to that, it's your sampling techniques. And we'll talk about this a little bit later, but the idea of like building a good algorithm requires, lots of data and lots of high quality data. And so if, again, it depends on the outcome, but say turnover, for example, you don't want to just take one snapshot in time, right? A good kind of turnover prediction model would be looking at different samples of data from the same people over, a long period of time. And then within that, those algorithms are continually learning and updating both at an individual level, but also at a group level. And so that way you're able to start normalizing out some of the life cycles or the natural rhythms of life, where things go up and down and different experiences happen to you. But yeah, it's about taking a very broad look, sampling it correctly, and getting high quality data. That's the way.
Yeah. So just to rather quickly take the opposite perspective, algorithms, we can't throw them out because humans aren't that great either, and that's why algorithms have come about. And so despite everything we're saying about algorithms, let's not dig ourselves into a hole. We all know Kahneman's system 1, system 2. System 1 makes lots of mistakes, lots of emotional and biased judgments, takes lots of shortcuts that can also cause a lot of damage. And the old way might have been something like this, which is quite funny, but also was probably the reality and is still the reality in many places. And that's why we try to introduce more objective ways of doing things, and algorithms have the benefit of being objective as long as we don't mess them up, and we create them in ways that work, right? And so this is an example of obviously the underrepresentation of women in senior levels of organizations. Finally, in terms of human biases, right? And this is a holistic bias on using AI and algorithms and just running to the latest shiny object. This is what we tend to do. I think we're all guilty of this. We don't want to be left behind. So this is a famous study where, you know, it's like which line is longer or shorter, and if everyone says something that's nonsensical, the one person who's not in the experiment will follow suit, right? And so exhibit 1 is most similar to which line, and everyone says B, and then they find that the 10th person who's the only one not in the experiment is like, oh, it looks so much more similar to A, but fine, it's B, right? And so we do that ourselves, and we are all looking to use algorithms. We have to make sure we use them responsibly. That was the takeaway. So how do we diffuse these weapons of mass destruction? No magic bullet, no quick answer to it, but can we trust tech firms and the companies that hold this data to regulate themselves? No, unless you want to trust the guy on the left. But even Bill Gates, who you'd think would be maybe saying we can trust tech companies, is agreeing that no, we need governments to regulate these things. Tech companies and the companies that hold the data are always ultimately driven by the bottom line. Government needs to be our protection and hopefully not be using it themselves. And so
when you're building these algorithms then, so assuming that first off, we can't trust them to regulate themselves, we need to start as vendors, as educators, as maybe even developers of these algorithms, we need to start holding ourselves and each other to a much higher standard, because that's where the change is going to happen. And so, you know, when we want to create and remove bias from AI algorithms, it's always, again, to the point I made to Tony, it's about starting with high quality data, and you want lots of it. But then actually, once you've captured that, it's about being a devil's advocate. And this is to Uri's point, it's about like, what are you trying to predict? And really be kind of real around what that prediction is. You know, I'm predicting with certainty, with 80% certainty that someone is an extrovert, for example. Well, that measure of extroversion is based on how they responded to a survey. So really what I'm saying is my prediction is an 80% accurate prediction of how someone is going to respond on the survey. Now, whether that survey is, you know, an accurate measure of someone's extroversion, if extroversion is even important, you know, it's about understanding what that data is, what it's really representing, how it's captured. But then the last few points here, it's about really understanding kind of who is accountable here. I think oftentimes we look to algorithms, the reason why we're so attracted to them is that, you know, we don't have to think. We now have something to blame, we have something to praise. It's removing that accountability, but this is the fundamental problem. Like at the end of the day, the algorithms are just a tool used by us making our own decisions. The algorithm didn't will itself into existence, nor did it will itself into the position of it being used. And so ultimately it's about understanding, you know, what are we trying to achieve with this? How does it work? But ultimately, you know, who's going to be held accountable, you know, when it's used? And importantly, if it has bias, you know, who is going to take that blame? And I think if we was really clear and structured about that, we'd start to see these things used in a much more fair and transparent way. And then so, yeah, so then leading with that, then there are kind of 5 very practical things to do. One is understand your own psychology around bias, but also privacy. I think there are various things, some of these heuristics that you see on the screen now, that are engaged and leveraged by technology companies that force us to, or influence us to give up our own privacy. But some of these are very innocuous. And when we're developing algorithms or technologies or systems, we should actually be more mindful of this. Are we actually getting more data out of people than we really need? Are we inadvertently enabling people to give up their privacy? And that ultimately is something that we need to kind of reconcile. We should only use data as and when we truly, truly need it.
Yeah, and instant gratification on this list, clearly the case of the company in the corporate wellness example, right? They are using instant gratification to get their employees to pay $10. It's not a lot of money, but employees are thinking it's just data, it's free, I don't care, I'll just take the $10. And so that's a good, we don't want to use these as well. We don't want to fall victim to them, so worth us being aware, but we also don't want to use them as vendors or as corporate HR officers. And
So
then,
of course,
go ahead, Reece.
regulation as well. I think not much to say about this one other than it's clear that we need it. It's clear that other parts of the world are using it, and it's being introduced more and more here in the US.
Algorithm audits is super important. If you don't have algorithm audit function in your organization yet, our recommendation is implement it. It doesn't have to be a big CHRO or CEO initiative and a big PMO office. It can be done at a functional or a group level. It's just which algorithms are we relying on to make decisions that impact people, and let's make sure that they are not WMDs. They're transparent. They're not scalable. They're not hurting other people. And you've got to do it routinely, so that because new things are constantly being introduced, new functions, new groups. There's a new tool. There's a new platform. I'm going to use that, and so it has to be something that happens quarterly or so. And if everyone has this in mind, it'll happen across the organization, and it'll be a more fair one. Education and diversify, I mean, that is super important, right? And so because a big part of the problem here is that there's not enough representation in developing these algorithms. And so people don't notice the fact that there's a lot of bias in the testing groups of the algorithms themselves. And so this book, Invisible Woman, is focused on that. And my friend over at MIT was mentioning that to me as well, right? If 90% of the engineers are white men, who's there to notice that, hey, all of our test subjects and all the people that we're running these things on are also happen to be white men. It just doesn't occur to them. And so having high levels of inclusivity and working harder to bring different perspectives into the process of creating these tools is a fundamental way of addressing the challenge. And finally, the algorithmic Hippocratic Oath, which comes from Cathy O'Neill, which I just absolutely love. But ultimately, it speaks to the fact that if we are not committed to fixing it, then the problem will just get worse and worse. And so if we require everyone who works on algorithms, data scientists within HR, to take the Hippocratic Oath, it'll, I think, change the way they think about what they're doing and what their goals are. Yeah, I think that's, I think we're close to time. If there's any last questions, then happy to take them.
If you have questions, please unmute yourself.
I have another question.
Yeah, great, Tom.
Sorry.
No, great.
I'd be fascinated to hear how your conversations with potential clients that are using this, what's the feedback? Is it like really enthusiastic? Is it, skeptical?
Mm-hmm. It's funny you say that, because it's, as Uri said, when we first started Deeper Signals, it was all about using passive machine learning algorithms to kind of profile people from afar. And then, the more we started thinking about it, the more conversations we had around privacy, morality. It's decided that's just not where we want to play. That's not how we want to be. And so now we've completely done a 180 on that, and our algorithms are designed to be transparent. And we talk about this, like our personality tools are not a black box. We're happy to explain kind of how they work, how they're scored, and why we created them. And I think that the general response to that has been a breath of fresh air, in that people are kind of happy to, they want to know how things work, rather than just been sold this is the magic kind of talent assessment that just works, and don't ask any questions because it's too intelligent for you, and it's this mystical science, whereas in fact, like, no, we want people to be understood. And a part of that has got to be, they've got to understand kind of how we're measuring them.
Tony, we go to market oftentimes with the mantra of personality is not prophecy, which is the reality, and it speaks to number 4 over here, right? Make your assumptions explicit, right? Personality science has error margins like every other science. You can take an assessment and have a wrong result, which is not something you often hear from some of the big players out there. But that's key if you really want to be honest to the science, right? It's a good estimate of how you probably are perceived by others on a normal day. It's very different than saying, this is your personality and you're done. And even if an organization is making a hiring decision based on it, which is not what we do because we don't love it, but even if in those cases, you can be honest by saying, we're going to make this hiring decision because more often than not, this is the profile that is successful in this role, and most likely your profile is accurate, and therefore we're going to take this shortcut because we have no choice, because we have 20,000 people we have to assess, and etc. But it's very different than saying, we've taken your DNA, we know your genes, and we're 1,000% confident that you're going to fail at this role, so goodbye, right?
Which is when we look at kind of the HR talent space in general, that's increasingly how it's going. It's like, play this game, and depending how you play in this game, you're now into the talent pool and you're stack ranked, and you either meet the cutoff or you don't. And if you don't, see you later, goodbye. That just doesn't seem to be the right way to go about it. That's an algorithm that's serving the organization and actually harming the individual, because they're left time spent, but also no idea why they didn't progress through to the next round of the hiring process.